Let's take a closer look at the OSI reference model. Let's start with layer 1, the physical layer. The physical layer is concerned primarily with transmitting data bits, which are your zeros and your ones, over a communication circuit. This layer is going to define the rules by which ones and zeros are transmitted, such as voltages of electricity, number of bits sent per second, and the physical format of the cables and connectors that are used. This is all about the physical parts of the system. Moving right along to data link layer, which is layer 2. And one thing I should just point out, when you get into your line of work, whether it be a networker or cybersecurity professional, when folks make reference to the model, they'll make reference not to the OIS model, but they'll make reference to the different layers. So right now we're in layer 2, which is the data link layer, which manages the physical transmission circuit in layer 1 and transforms it into a circuit that is free of transmission errors as far as layers above are concerned, because layer 1 accepts and transmits only raw stream of bits without understanding their meaning of structure. The data link layer must create and recognize message boundaries. That is, it must mark where messages start and where it ends. Another major task of layer 2 is to solve the problems caused by damage, loss, or duplicate messages, so the succeeding layers are shielded from transmitting errors. Thus, layer 2 performs error detection and corrections. It also decides when a device can transmit so that two computers do not try to transmit at the same time. Let's dive into layer 3. That's the network layer. The network layer performs routing. It determines the next computer the message should be sent to so that it can follow the best route through the network and finds the full address for that computer if it's needed. Layer 4. We also call it the transport layer. The transport layer deals with end-to-end issues such as procedures for entering and departing from the network. It establishes, maintains, and terminates logical connections for the transfer of data between the original sender and the final destination of the message. It is responsible for breaking large data transmission into smaller packets, ensuring that all the packets have been received, eliminating duplicate packets, and performing flow control to ensure that no computer is overwhelmed by the number of messages it receives. Although error control is performed by the data link layer, the transport layer can also perform error checking. Layer 5, also known as the session layer. The session layer is responsible for managing and structuring all sessions. Session initiation must arrange for all the desired and required services between session participants, such as logging into circuit equipment, transferring files, using various terminal types, and performing security checks. Session termination provides an orderly way to end the session as well as a means to abort a session prematurely. It may have some redundancy built in to recover from a broken transport connection in case of failure as well. The session layer also handles session accounting so the correct party receives the bill. Layer 6, also known as the presentation layer. The presentation layer formats the data for presentation to the user. Its job is to accommodate different interfaces on different terminals or computers, so the application program need not worry about them at all. It is concerned with displaying, formatting, and editing user inputs and outputs. For example, layer 6 might perform data compression, translation between different data formats, and screen formatting. Any function except those in layers 1 through 5 that is requested sufficiently often to warrant finding a general solution is placed in the presentation layer. Although some of these functions can be performed by separate hardware and software, for example, encryption. And last but not least is application layer 7. The application layer is the end user's access to the network. The primary purpose is to provide a set of utilities for application programs. Each user program determines a set of messages and any action it might take on receipt of a message. Other network-specific applications at this layer include network monitoring and network management. That is your 7 layers of the OSI model. It won't come out. And what I want you to do is study this worksheet. And if you understand it, if you don't understand it as well as you feel you should, then I have some other reference materials that are stored under the resources link. And if you would just go through those, and there's a video link as well, you should be prepared for the final assessment. If you have any questions, feel free to click on my link and ask me, and I will return a response back as promptly as possible.